revision paper for term 3. Alright. The diagram below shows the transport of food and water in plant. So therefore, this is when we do a topic, what we want to identify is which topic is this on. So we know that transport. So when it comes to transport, it's always from where to where. Okay, from where to where. In this case, transport in plant tells me that I'm looking at my xylem and my phloem. So for my xylem and phloem, my xylem is actually my water carrying tube. And my phloem is my food carrying tube. Okay, so what does my food water carrying tube carries? It carries, very important, water and and dissolved mineral. From where? From roots to all parts, especially the leaves. Okay, now my food carrying tube, it carries sugar. Alright, from leaves to all parts. Now take note that this is one direction. The flow of water is one direction. This is both ways, both directions. So what does one direction mean? That means that it can only go from your roots to all parts. It cannot be all parts to your roots. It doesn't work that way. Whereas your food, right, it can go from your leaves to all parts. It can also go from all parts back to your leaf. So for example, storage roots, like your potatoes and your tapioca, they will store it at your roots, excess food. On days that there are not enough food, say not enough sunlight, your leaves doesn't make enough, they can break down the starch in your roots and then it gets transported to your leaves. Bidirectional, we call this. So this kind of question is very common. The first thing you need to do is to identify your roots. Okay, because your roots always carries water from your roots to your leaves and all parts. So movement of water is solid line. Okay, so look for it. Where is the origin? So is it Y? Is it X? Okay, you will take note that it actually originated from Y. So because this one carries water, so this has to be my roots. Okay, and you check that it is one direction. Okay, it is one direction. Correct. And it passes through your stem. Okay, then after that, you go to this unknown, your X. Your X is the one that transports food. This part X is the origin of your food. So it has to be your leaves. Right? So food in the form of sugar. Okay? And then it has to go to the stem first before it goes to anywhere else. So food that is made here goes to here before it gets distributed. So my answer is leaf and roots. Next. Okay. Deepa remove food carrying tubes of a plant as shown. Okay. Explain why the leaves die after some time. Now, there are many variations of this type of question. This is a star question. Don't say I never say. So there are many variations of this question. What do I mean by that? If I have a plant, okay, never mind about the ugly drawing, okay? These are leaves. The green part are the leaves. And then after that, this is the fruit. Okay? Now, it really depends on where you cut the plant. Where you cut the plant. If you cut the plant at the main stem and you remove the fruit carrying tubes over here, the whole plant will die eventually. The whole plant will die eventually. I will explain to you why. So let's make a few cuts and then you understand. Cut A, cut B, cut C. Okay? Now listen to me very carefully with my explanation. Okay? So, your leaves are able to make food. Remember this, they can make food. Okay? As long as they have water. As long as they have water, they usually won't die. That is the first rule of thumb. Because if they can get water, they can actually make food. So you have to read the question very carefully. Did they remove both the food carrying tubes and the water carrying tube, or just the food carrying tube? Read carefully. Okay? Now, if the cut was made at B or C with just the food carrying tube removed, your plant will not die. Your plant will not die. No problem with B and C. Okay, why? So in the most basic scenario, okay, water can still be transported from your roots up to your leaves. No problem. Your leaf will still be able to take in sunlight, water, and carbon dioxide for photosynthesis. So it can make food. No problem. But what is the consequence of cutting it here then? The consequence is that the food now that is being made by the leaves in red can no longer go below the point C. When you answer this question, you have to tell me, if there's only one cut in this question, okay, it's just a cut, full stop, done. But if they have cut A, B, and C, you have to tell me which point did you cut at. So food cannot be transported from the leaves below point C. You have to use the term below point C. I repeat again. Food cannot be transported from the leaves below point C because food carrying tubes are removed. That statement, food carrying tubes removed, must be there. The consequence would be then it starts to swell. Why swell? Because there is an accumulation of food. Okay, so it swells. Scenario number 1 for cut C. Scenario number 2 for cut B over here. So water can still be transported from your roots to your leaves, okay? No problem. Your leaves will still happily photosynthesize, sure, okay? But scenario number 2, the difference now is food made from the leaves cannot be transported below point B. Cannot be transported below point B. And so instead of accumulation of food here, now what happens is the food will go to your fruit, making it bigger. And any food that is stored here is not excess food will be stored in fruit. Is more excess food will be stored in the fruit. Okay? Why? Why must more excess food, cannot just excess food? Because you think about it, any food that you already store in a fruit, it's already excess. Without your without having any excess food, if your plant is already starving, do you think it will produce fruits? No, it wouldn't. It needs to, it's all excess food. So it's more excess food and your fruit becomes bigger. That is the outcome. Okay? The last scenario. The last scenario A. Because the food carrying tubes were removed at this point and your roots have no way of making food on its own, the whole plant will die eventually because the roots rely on your leaves to get food. So if you cut it here, all the food cannot go down towards the roots. Cannot go down towards the roots. And what would happen is that, okay, while your leaves may be very busy making food, all the food cannot go past point A. Eventually, your roots have no food. And eventually, it will die. So when it dies, water can no longer be absorbed by the roots. If the plant has no water, the leaves cannot receive any water to photosynthesize. No photosynthesis will happen. The whole entire plant does not get food. Eventually, the whole plant will die. So 3 different scenarios at 3 different cuts. Okay, when it comes to removal of your food carrying tubes. So if we were to write this, okay, you will first say that as food carrying tubes, or if you're very good, you can straight away say phloem, were removed at the cut, no food can be transported from the leaves to the roots. Okay? Roots will die and no water can be absorbed. No photosynthesis can occur as the leaves cannot receive any water. Okay, where are my marking points? Crucial, you must always tell me that what tube was being removed. So in this case, food carrying tubes were being removed. Okay, and then what's the outcome? So no food can be transported from where to where. Then what will happen? Roots will die. A lot of you didn't bother to tell me the roots will die. So because root die, water cannot be absorbed, and so no water can be absorbed means that no photosynthesis can be occur. Okay, as leaves cannot receive any water. So a lot of you actually phrase it in no water can reach the leaves, or there is no water for the leaves to photosynthesize. I want you to break this point into 2 separate points, okay, and I want you to focus on saying that no photosynthesis can occur. No photosynthesis can occur, okay, because there is no water. Don't tell me things like the leaves has no water for photosynthesis, but maybe it has other things, okay. I don't want it to be presumptive like that. Okay, this question can also come in the form if let's just say water carrying tube. If water carrying tube is removed, no need to say already. 100% whatever that is the leaves here will die. Okay, all will die as long as it removes the water carrying tube. Simply because what process cannot happen? Photosynthesis. That's it, full stop. So it's always the one with the food carrying tube that is more tricky because there are 3 different scenarios. But for water carrying tube, that's it. The leaves above it will not photosynthesize. Okay? But it doesn't mean the whole plant will die. So for example, right, if you cut here, only this part of the branch will die off because no water. If you cut here, only this part of the plant will die because the rest of the leaves can still continue to produce food. But if you cut here, obviously the whole plant will die because the water cannot go up to any of the leaves, right? Okay, next. Okay, next. Okay, Hannah set up the following experiment to find out how the amount of carbon dioxide affects the rate of photosynthesis. This question was really so poorly done. Amount of carbon dioxide. Okay, so this is the aim. How do I know that this is the aim? To find out the next thing. Carbon dioxide is my change variable. Rate of photosynthesis is so-called my measured variable. Right? So basically, based on the above results, what can Hannah conclude from the experiment? So in this case, right, okay, the answer is asking you from conclusion. Many of you gave me relationship. Okay, so what do you say? You say the more number of scoops of baking soda, the more number of bubbles produced. But my question to you is, what was the question here? How the amount of carbon dioxide affects rate of photosynthesis? Are you answering the question? They never ask you what is the relationship, They ask you the conclusion. So your aim is this. What is your conclusion? So in it, I must say amount of carbon dioxide. So number of scoops actually equals to carbon dioxide. So the more number of scoops means the more number of carbon dioxide, isn't it? Okay, and then how come there are more number of bubbles? This is your oxygen. Your oxygen is equivalent to photosynthesis, isn't it? Something that we learned. So when you answer this, you need to say as the amount of carbon dioxide increases, the rate of photosynthesis increases. So be careful, is it a relationship question or is it a conclusion question? This is a conclusion question. What can Hannah do to make her results more reliable? I've taught you this many times. You need to say, repeat the experiment at least 3 times and take the average. So if you just gave me at least 3 times, this is only half a mark. You must say take the average, this is the other half a mark. Okay, it is a standard answer. It is what it is. Okay. Now, if you want to actually, use increased sample size, you must tell me how do I increase sample size. Increased sample size means that instead of conducting one experiment, you conduct 10 experiments, okay, at the same time. So this is one setup, right? So this is one setup, correct? This is one whole setup. So you need to multiply this setup by 10 times. And then you all start at the same time. Everything else must be the same. It's just like you go for the vaccination is approved for everyone, for us to take for COVID-19. They will trial it for a few thousand people. So the few thousand people, okay, is the sample size. Instead of testing on one person, you test on 1,000 people. Okay? And if the 1,000 people give you the same results or similar results, we say that the results are reliable. Okay, this question. Name the process that occurred in the leaf that allow it to rise upwards. So isn't it quite straightforward? Ask yourself, what is this bubble under the leaf? There is light. So this will have hinted you that this is photosynthesis has occurred, and this photosynthesis has produced oxygen O2, right? So this O2 acts like a float, okay, to push the bubble up. So the answer is just photosynthesis. Quite a number of you have broke down the answer as respiration. And then you say how it releases carbon dioxide. But this cannot be the case. Let me explain to you why. Because there is a light source. So we assume that when there is a light source, photosynthesis has occurred. Okay? Am I saying that the plant does not respire? No, absolutely not. I have told this class more than 1 million times. Respiration happens every single second, every single moment, every single waking hour, sleeping hour, I don't care. It's 24/7. It's an all-time affair, okay, for all living things. But the difference is that the rate of photosynthesis in production of oxygen is higher than what the plant is using for respiration. So for example, if the plant it produces 100 units of oxygen, but it only uses 10 units for respiration, it still have 90 units to release. And that's why you will still get the oxygen here, even though it is respiring. This is a concept that you must understand. Okay? So explain how the above process. So during photosynthesis, oxygen is produced and released via the stomata under the leaves. Okay, the oxygen pushes the leaf upwards. Now the second part I did not mark you down if you never put, because this is a force question. That means a forces question or in a P6 topic. Okay, so I awarded you the mark as long as I see oxygen is produced during photosynthesis. But when you go up to P6 and after you learn the topic of forces, you know that a force is a push or pull. So the oxygen pushes it up or carries it up or somewhere along those lines. I need to see, but actually the key point is pushes and oxygen is produced. So if you tell me air, you tell me carbon dioxide, you tell me any other thing, I don't accept. I only accept oxygen. Okay? Next. This question is very important. Very important. Okay, it is a standard question. Let's take a look at it. So the key thing is already when you see the bulbs and batteries are in working condition. So this tells me that it's not fused, it's not whatever. Okay? Now, when material X was placed in a circuit, bulb A did not light up. So don't tell me things like, oh, bulb A was spoiled, the battery was spoiled. It's like, no, it's got to do with material. And usually when you think of material in terms of electrical circuit, there are three things that you need to think of. Is it a conductor? Yeah, let me find a nice space. Okay. Is it a conductor of electricity? Or is it an insulator of electricity? Okay, don't tell me that it's a non-conductor or it's not a conductor of electricity. If it's not a conductor of electricity, then what is it? What is it? Cotton candy? No, I'm being serious here. So in the eyes of the examiner when we mark, we always try to understand. Though we know what you're trying to say, but you're not using the scientific language, insulator. So for those of you who tell me what non-conductor lah, no, I only want to see insulator. If you're not a conductor, then you must be an insulator. It is what it is. So because it is an insulator, it does not allow electric current to flow through it. So it is an open circuit, your CEO. Where is it? Where is it? Okay, and then after that, the last one, is it magnetic material? Now this one usually please don't hold me ransom and say Mr. Chong say one usually only if there is an electromagnet, then you're concerned with it. Do you see an electromagnet in this circuit? No, right? So obviously you know that probably it's got nothing to do with this. Okay, it's probably got to do with this. That's about it. Okay, so this is like a hack lah for you. Okay, if I don't see any electromagnet, there's no coiling of any iron rod or steel rod. Okay, it's probably not got to do with magnetic, because a lot of you also wrote magnetic. What has got magnetic got to do with this? No. And the confusion comes with the fact that usually when materials are magnetic, it happens to be a metal, and metals are good conductors of electricity or poor conductors. Okay, but no, not in this case. So it tells you that it didn't light up, right? So remember, even me, after I tell you 10 billion times, of course, nobody will care about me. I know one. Because until now, when I mark your paper, you go and see how many of you didn't use CEO to answer. So in this case, let's be honest, the O has already been answered. Where? Light bulb A did not light up. Finished already. So what must you use? C and E. Even if you answer O inside, is fine. No wrong. But I'm just saying that because the O is already here, you have to talk about C and E. So X was an insulator of electricity. Right? That's the first marking point. The second marking point usually worth half mark only nowadays, because everybody already know already. Hence, the circuit was open. Right? And electric current cannot follow through. The circuit. Okay, so this is my C, my circuit, and then my O. My O is already here, so my E is here. So during exam, I want you to write down CEO and check it off every time. I know that daily assignment, you all really cannot be bothered, some of you. But tomorrow, please, really, I say until I don't want to say anymore. CEO. You see electric circuit, CEO. CO, CO, CO. It is what it is. It cannot be anything else. But you all just refuse, simply refuse to listen to me. I don't know why. State a possible material that Alicia could replace X. Okay, so possible material will be copper. Okay, iron also can. Some of you put gold. Gold is not wrong. I gave you the marks. But you see, it's not realistic. Gold very expensive. But yes, it will work. In fact, it's one of the better electrical conductors. You find it in your handphone circuits, your very expensive electronics. Next. Okay, another electrical setup. Okay. Now, what arrangement of the bulb shown in the diagram above? Parallel law. Okay. Now we're talking about the bulbs. See how they always refer. The bulbs are in parallel. Don't just tell me okay. Oh, the circuit is parallel. Which part of the circuit is parallel? Is it the batteries, the bulbs, the wires? We want to say the bulb. I say many times already. Okay, state one advantage. Now, I am going to tell you what is the advantage. On top of that, I'm going to tell you explain also. Explain. Why? Because for electrical circuit, it is important that you know how to explain. Okay, especially for parallel circuit. So you would say that, okay, when one bulb uses, okay, the other bulb remains lit. Okay, why is that the case? Okay, you would say that electric currents have an alternate pathway to flow. Circuit remains closed. Okay? The key idea is alternate pathway to flow. And the circuit remains closed. Okay? So, a lot of you say, oh, same brightness. But you see, same brightness may not always be an advantage. It depends on the case. For example, what if you don't want your battery to run out so quickly? Right? You think about it. If your bulbs, so it depends on the scenario. So if you're given a scenario whereby you need all the bulbs to be in equal brightness, yes, then I would say by all means that is an advantage. Okay? But then in another scenario, that may not be the case, especially when you're trying to conserve battery. So therefore, the answer for this, the best answer is when one fuses, the other remains lit. Okay, because in this circuit, you intentionally, okay, have to. Next, okay, is another electrical circuit. Okay, come on guys, repeat after me. Echo. What is the three magic letters? CEO. Excellent. CEO. The only thing I want to know is CEO, okay? Let's see. Oh, but it's here, the CEO is here. This is drawing first. Okay, fine. Still CEO. I don't care. Somewhere, as long as you know it's CEO. Okay, now draw a circuit diagram. So I'm going to tell you what I'm marking for. When it comes to drawing of diagrams, it cannot be too small. It must occupy at least half, if not 3/4 is the best of given space. Then after that, everything must be connected without gaps. No gaps at all, please. Okay, and no hairy line. And no, it does not have to be curved. It's a circuit diagram. So some of you all like to do this, I don't know why, like drawing like Picasso like that, oh, must like that. Yeah, and then after that, you all don't laugh, okay? I have people doing this to me. I want to, scold people already. This is the bug. And then you just happily draw the wire through it. Okay? You don't laugh. It is what it is. Okay? And then the battery also don't care. Battery is supposed to be like that. Positive and negative, right? Don't care. Just draw through the whole thing. No, it is. This is wrong. These are all wrong. I'm going to show you how to draw it. So over here, so no, you do not have to be a curve. Just because this is curve, you also curve. And they said circuit diagram. Circuit diagram means you must use symbols. Some of you are really like artists like that, You follow exactly what was being drawn. Then what's the point? No, the symbol for this is a circle and a cross. Okay, not a plus. Some of you did this. Don't laugh. Okay, I'm showing you what your friend did. I know this is not a screwdriver head. Plus and minus screwdriver head. No, wrong. And then after that, your batteries. This is the positive end. This is the negative end. Positive end, negative end, positive end, negative end. 3 of it. Don't draw 1. Don't draw 2. Draw 3. And have the orientation correct. Some of you, the orientation was the other way around. It's fine as long as I make sure that it works. Your switch looks like this. Okay, if it's closed, draw it closed. Just like that. Can already. If it's open, draw it like this. The wires are connected at the side like that. So this is closed. Okay, that's about it. So let's put what we've learned. Use pencil. I say 10 billion times, but of course nobody ever listens to me again. So draw your bulb across. Okay, after that, check one bulb. Then after that, you have to draw your wires. Okay, and you have to draw your battery. Okay, fine. I'm going to draw my battery. Positive, negative, positive, negative, positive, negative. Okay, then I join the wire with my ruler. No, this is the correct way. Positive is this side, longer. Hello, whoever tell me that I drew the wrong way, open your eyes. Then after that, go straight. Go straight. Then after that, what do you have? You have your switch. Okay, I drew this a bit too small. Don't follow me, okay? But because of perspectives, it's closed. Join. Make sure that everything, okay, it is actually nicely joined. I don't want to see any gaps, any heavy lines. Okay? Also, one more thing. Don't place your electrical components at the corner here. This is wrong. Okay, so you put a switch here, put a bulb here, all wrong. Alright? Finally, the last question, which is very important. Very important. So, all eyes on me. This is so important. If you see, I'm going to erase away all this. If you see this part here, you see a wire cord around steel bar. So once again, let's revise. Magnetic material is what? Shh, no, coins. So CO stands for copper, I stands for iron, nickel, and steel. So, shh, quiet. So you see? Oh, sorry, yes, cobalt. Sit down. Okay, yes, thank you very much. Okay, cobalt. Okay, yes, this is a common error. Okay, but last time I told you correctly, right? It's cobalt. Okay, so basically, please take note if this is a magnetic material and there's a coil around it. Definitely, almost 99%, there is an electromagnet somewhere in your answer one. So you have to put it there. That is usually your outcome, your O. Your O needs to be this one. Something will happen and then cause it to hit the hammer to ring the bell, whatever. Okay, so let's answer this. Explain how the bell rings. Okay, so first thing, see, okay, when the switch is closed. So let's go. Okay, when the switch is closed. Okay, my first C. Circuit is closed. And then my E. Electrical currents can flow through the circuit. My E is done, right? My C is done, my E is done. What is my outcome? So remember, there is an electromagnet. So I need to say about the electromagnet. So the iron rod, is it iron rod or iron bar? Okay, iron bar.
Steel bar.
Oh no, sorry, steel bar. The steel bar becomes an electromagnet. I say already, cannot just say magnet, cannot say temporary magnet, must say electromagnet, and attracts. What does it attract in this case? Attracts the iron hammer. Okay? The iron hammer, which will hit the gong. Okay, where are my marks? So usually these two circuit is closed and electrical current is worth half mark only. Together nowadays they mark like that. Okay, usually I can change one steel bar becomes an electromagnet. Okay, half. Hits the gong, no, attracts half. Hit the gong is another half. Why? Because they said ring. So in order, oh sorry, hit the bell. Hit the bell. Okay, but you all get what I mean, right? Okay. So because it's about ringing it, so it has to hit. Just by it attracting it, if the hammer doesn't hit the bell, it doesn't ring. Okay. Now, in this case, you just only have to talk about how it rings. Because it never say ring stop, ring stop, ring stop. Okay, so if they say ring, dot dot dot, ring, dot dot dot, ring ring. Then the dot dot part you have to explain already. But because this time they never give that scenario, it's just ring. Okay, fine, close can already. So my O is done, check. Okay.